Today's topic is Basics of Precast Concrete Technology. In this topic, we will go through these points. What is meant by precast concrete? What are advantages and limitations related to that? What is the process that is adopted for the manufacturing of these elements? What are the applications in various fields? And how these elements behave when subjected to seismic forces? Concrete. It's a very common word and familiar word to all of us. Concrete is used for the manufacturing of beams, columns, slabs, irrigation dams, canals, bridges, and many more things. So when these elements are manufactured or casted at the site itself, it is called as in situ technique of concreting. But when these elements like beams, columns, slabs and other requisite elements, if they are manufactured in the factory and they are brought to the site for assembling and for erection, this technology is called as precast concrete technology. So if you want to define precast concrete technology, it is basically off-site manufacturing of concrete elements. Off-site means, of course, in the factory. So there are various processes which we execute at the site. Same processes are executed under quality supervision, using quality ingredients and following all the specifications recommended by Indian standard. These elements are casted or manufactured in the factory. Once they are manufactured, they are brought to the site and they are assembled. And finally, a building or a structure is erected. This technology is called as precast construction or precast concrete technology. Now, this technology is also governed by few specifications. These are the specifications which are given by or rendered by IS 15916-2010 and IS 15917-2010. These are the IS codes which deal with the prefabrication process and erection of these precast elements. These IS codes specify what are the criteria to be followed while manufacturing these concrete elements, while transporting these elements, what are the tolerances which we have for the manufacturing, what are the precautions we should take while handling these elements, while transporting these elements and erecting these elements. So when we follow these IS codes, definitely the quality construction would be available to us. Next we have why this precast concrete technology is so popular. Yes, it is very much popular in foreign countries, although it is not that popular in India. But nowadays many of the companies are preferring these precast concrete elements. So what are the benefits or highlights or key points related to precast concrete technology? Optimization of project duration is possible with precast concrete technology. How? Because in situ construction is affected by weather condition. It may be interrupted due to rains, summer or shortage of laborers. But this is not the situation with factory made product. This way it optimizes the project duration. The second point is it enhances construction speed. When number of elements are manufactured with the same size and specification, these elements will be ready in the same duration of time. So these elements will be ready to use. It will be taken to the site and installed and your building is ready. So it improves the speed of construction. Third, high standard of workmanship. All these elements are manufactured in the factory under skilled supervision using standard machineries. Hence, the workmanship which we get in this technology, it is far better than our conventional way. Next point is high quality finish. The ingredients which we use, their specifications, the material which is used for formwork, the processes which are adopted for placement and compaction of concrete, the duration which is given for curing, all these things are meticulously followed. Hence, the product which we get, it is a quality finished product. Therefore, these elements, precast concrete elements, are preferable over our conventional concreting elements. Now these elements are manufactured considering these 6 factors, out of which 3 are primary and 3 are secondary. Primary factors are, it should be waterproof, okay, it should be dense, it should be compact kind of concrete element. Water should not pass through, seep into the element, so it should be waterproof. It should control radiation and heat, it should be resistant to that. It should control sound, means it should be an acoustic material. What are other 3 factors? The expansion and contraction happening due to thermal and moisture movement, it should be within control. It should resist that. It should resist fire, and it should be possible to install these elements very easily. It should not demand any high skill of jointing method or installation method. There should be a proper planned erection procedure available with this site engineer. So this way, keeping in view these 6 elements, these precast concrete structural elements are manufactured in the factory. Now we will see the highlights of precast concrete technology. What are the advantages and limitations? So the first advantage is design build efficiency. Precast concrete offers an efficient delivery model to a project. When a building is designed, immediately the requirements are given for the manufacturing of the elements to the factory. Once these elements are ready, those are transported to the site for installation. For the next level of design, again the requirements are given to the site, thereafter to the factory, and accordingly the process is repeated. In this way, it becomes design build efficient model. Second is, it is an aesthetically versatile material. These precast concrete elements can be manufactured in any shape and size, virtually of any color, and also with multiple varieties of finishes. Hence, this becomes an aesthetically versatile material. It reduces cost. How? Precast concrete products are manufactured off-site under a roof, and they are transported to the site as and when required for installation. This compresses the project duration. This cuts short the requirement of labors at the site. At the same time, only few people and agencies are involved in the manufacturing of elements. This way, it reduces the overall cost of the project. Next point is environment resistant or weather resistant. This precast concrete structure is a very good weather resistant material. It can withstand rains, thermal changes, it can resist attack by the insects, it is a fire resistant material. So overall, it is a very good environment resistant material. Next is thermal efficient material. Concrete being a good material to resist the change in temperature, it is a thermal efficient material. Next is low maintenance. The exterior of a precast concrete structure exhibits a very good quality of finish, hence doesn't require any plastering or painting. But if at all we have gone for painting, repainting is expected after 5 or 10 years. So it is a very good material with less maintenance. Also, the interior portion of that precast concrete element can be washed and maintained without any damage. Next point is sound control. Because of its density and compactness, it becomes a good sound insulating material. Thereafter, Wi-Fi compatible. Yes, with the increasing demand of internet facilities and Wi-Fi facilities, these elements are pro-technology elements, technology friendly elements as far as internet facilities and Wi-Fi compatibility is concerned. One more thing, it is also a recyclable material, so it is a green material, it is an eco-friendly material. In this way, these are the advantages or benefits of precast concrete elements. What are the limitations? Limitations are flexibility in the utility of the structure, and second, connections between structural elements. See, all these elements are designed by a structural designer. Structural designer designs these elements as per the requirement in the architectural drawing. So, if an architect plans a residential building, accordingly a structural designer designs these elements for the requisite loads. Thereafter, the elements are manufactured. These elements are installed at the site and the structure is ready for the use. But due to some situation, instead of residential purpose, if that building is to be used for commercial or public purpose, it is very difficult to convert that structure into the second utility. The reason is all these elements are designed for the residential load purpose, not for the public or commercial building load purpose. And this flexibility is very limited in case of precast concrete elements. Second point which is mentioned, it is related to connections. These elements are manufactured separately, independently in the factory, and these elements are connected together at the site while installing. So their connections should be proper. Now we know all these loads are transferred through the joints only, through the points of contact. The point of contact between slab and beam is responsible for the load transmission. Point of contact between a beam and columns, it is responsible for transfer of load to the columns, and from the column to the footing, thereafter to the soil. If these connections, these joints are not proper, then it may cause cracks or damage to the structure. Hence, connections between structural elements are very crucial in this precast concrete technology. Now next is process which is adopted in the plant to manufacture these precast concrete elements. This flowchart has been taken from IS 15916. So what does it depict? It shows that there are four elements, basic elements in the concrete manufacturing. First is water, second fine aggregate, third coarse aggregate, and fourth is cement. These elements are mixed together with proper proportion. So measuring process is done, thereafter mixing process is done. Before going for feeding this concrete into the formwork, there are several processes which are parallelly done, like making of cages as reinforcement. So if mild steel is to be used for reinforcement, it is cut into the lengths required for the reinforcement. Second, it is bent, that is the cages are made and it is bound and then transported into the formwork, and thereafter the concreting work is done. Now instead of these mild steel reinforcement, if we want to go for high tension wires which has high tensile strength, those are called as tendons. These tendons are used for pre-stressing. So precast and pre-stress, these two processes would be adopted simultaneously. So for this also the process is mentioned in the flowchart, that it is threading and thereafter stressing. After finishing this, the process of filling of concrete is done. So concrete is placed into the formwork, thereafter it is compacted, then cured, then the molds are removed, it is demolded, formworks are removed, the elements are cured in the yard. Once the elements are ready, after 14 days or 28 days of curing as per the requirement, they are tested for the loads, expected loads, and thereafter they are transported to the site for final installation. In this way, the complete process of precast concrete elements manufacturing is carried out. Okay, the molds which are available after casting, those are washed, those are cleaned, and again they are made ready for concrete placement purpose. In this way, this flowchart depicts the step-by-step process which we adopt for the manufacturing of precast concrete elements. The next is application of precast concrete elements or precast concrete technology. So these elements are frames elements. So precast concrete frame construction. Now frame construction is done with the help of beams and columns. So these beams and columns are designed according to the structural requirement. They are reinforced and they are manufactured off the site. They are taken to the site and installed. While installing these elements, care should be taken that their joints should be filled properly so that there would be smooth transfer of load from beam to the column. The next application is precast concrete wall. These walls are used as internal wall or external wall. What are the benefits of these walls? Advantages. These walls can be load bearing or they can be only partition wall. They have smooth surface finish, hence they can be left as it is. They are weather resistant. They act as acoustic material. Speed of construction is greater and it is fire resistant. In this way, precast concrete wall construction has the advantages. The next application is precast concrete floor construction. Now these floors can be manufactured in 4 ways. 1 with hollow core, 2nd ribbed floor, 3rd as concrete roofing elements like Mangalore tiles, and 4th massive slab floors, our regular slab, solid slab. Okay, so in these 4 ways, if these precast concrete floors are available, these units can be taken directly to the site and they will be installed. Grouting of these elements with the beams should be supervised and should be executed properly for the proper transfer of load from slab to the beam. This way, there are 3 applications of precast concrete elements. First, precast concrete frames, 2nd, precast concrete walls, and 3rd, precast concrete floors. The next part is seismic performance of precast concrete structures. Now, precast concrete elements are assembled at the site. These are manufactured off the site, they are assembled at the site, and these joints play a crucial role for the transfer of load. Because this continuity is very much necessary for earthquake loads. Yes, it is necessary for gravity loads also, but for earthquake load which are lateral, these joints play a very important role. So how these joints are connected or made? These joints are made by 2 ways, one in the form of hinge joints and second in the form of equivalent monolithic joint. The first method is hinge joints or jointed system. In this method you can see there is a column or pillar. It has column head and on that head 2 beams from the other 2 sides they are resting. These 2 beams with the column head are connected through anchor bolts. What does this mean? This means whenever lateral load would come, that lateral load would be taken care with the help of these anchor bolts. So these anchor bolts will create a sort of monolithic effect with the columns. Hence, these joints are very much necessary to be strong. Now the next method is equivalent monolithic method. What is done in this method? You can see in the image, there are 3 precast elements. These precast elements are joined by anchor bolts and the remaining space between these 3 elements is filled with concrete. This concreting is done in situ. So this gives sort of monolithic effect. So a typical connection of exterior beam column joint and elements, it is shown in the diagram. Now let us summarize the topic. What we have seen in precast concrete technology. We have seen what is precast concrete element, where it is manufactured, what are the quality standards required for this precast concrete elements. So IS 15916 and IS 15917, these are responsible for the specification of precast concrete elements manufacturing. Now these elements have their own key points. We have seen those key points like optimization of a project duration, enhancement in the speed of construction, high standard of workmanship is possible, and thereafter high quality product we will get it. Thereafter we have seen what are the functions on the basis of which these elements are designed and prefabricated. So it should be waterproof, it should control radiation and heat, it should control sound, that is a good acoustic material, it should be a good thermal resistant material also, it should resist fire and easy for installation. After that, we have seen the benefits or advantages and limitations of these precast elements. So what are the advantages? Design build efficiency, aesthetically versatile, reduced costs, environment resistant, thermal efficient, low maintenance, sound control, Wi-Fi compatible, and a green material that is completely recyclable. Limitations are there in terms of flexibility to use the structure. The structure which is designed for a particular type of load cannot be used for other purpose which is expecting heavier loads on the foundation and the concrete elements. And second limitation is it is related to connections. All these elements are manufactured at the factory and installed at the site. So connections should be done properly for the transfer of load. Otherwise, those will be the weakest points in the path of load transfer. Thereafter, we have seen the processes which are involved in the manufacturing of concrete elements as per IS 15916. Then we saw the applications of these concrete frames, concrete walls and concrete floors in the field. So these precast elements are used as frames, that is for frame structure, for walls, that is internal external wall, load bearing or partition wall, and concrete floors like solid slab or hollow slab, ribbed slab, etc. This way we have applications of these precast concrete elements. At the end, we have seen the seismic performance or response of these concrete elements. So for this, joints are the important key points for the transfer of load, these lateral loads which are seismic. So these joints are designed in two ways. One is jointed system, hinge joint system, and second is equivalent monolithic method. So equivalent monolithic method is better than hinge joints. Hinge joints consist of joining the members with the help of anchor bolts, but gaps are still there between the members. But in case of equivalent monolithic method, as if it is cast in situ process of manufacturing these beams, columns and slab together. In the same way, these joints are filled with cast in situ concrete. Hence, it gives an equivalent monolithic effect. So it is better than hinge joints, so it gives better results. In this way, its seismic performance can be improved if precast concrete elements are used in a building. So this way we have seen precast concrete technology. Thank you for today.